Hey guys, so sorry your video is going to be a little bit late today. I was having a little bit of trouble setting up, so let me get this zoomed in properly here. Okay, so what we were talking about today was graphing sine and cosine. So we talked about our unit circle. So while you're listening to this video, have your unit circle in front of you, and we were talking about the 5-point method that I call it, right? So when you're graphing sine and cosine, we're essentially only worried about the x and the y axis here. And for the most part, as we start off, you're just going to be dealing with anything to the right of 0. So we're only going to have this. Now there's 5 points, right? We start at 0. And if we're dealing with just sine x or cosine x, we're going to be doing a full cycle, right? So we're going to be going around the circle once. And if you go around the circle once, you're going to be traveling 2 pi, right? So you have 0 to 2 pi. Then essentially, like I said, there's 5 points. So that's 1, 2. Now they're all evenly spaced. So you can just cut 2 pi in half in the middle and you have pi. And then if you cut pi in half, you have pi over 2. And because there's 4 equal parts, this is the third quarter, so it's basically 3 pi over 2. All right, so then here's your 5 points. So this is for sine or cosine. So I'll do cosine first, since that's our x output around the unit circle. And then I'll do sine x, because that's our y output on the unit circle. So we'll have 0, 2 pi, pi over 2, and 3 pi over 2. Okay, so you have these two graphs here, okay? So now we're going to graph cosine of x. Now, if you go around your unit circle, we're starting at the line 0. What is the x output at the point for the radians or degrees of 0? It's going to be 1, right? So that's where we're going to start. Now, the other one is going to be -1. So we're only oscillating between 1 and -1. What we call this oscillation of the maximum of 1 and the minimum of 1 is we call this an amplitude of 1. So our amplitude is equal to 1, right? Is that clear here? Okay, so our amplitude is equal to 1 because it only oscillates between 1 and -1. So our first point is 1. Then our next point when we go around the unit circle on the y-axis up on the top is going to be 0. And then as we go around to, so I'm just going to do this right here and do that. So here was 1, here was 0, here is, on your unit circle, is -1. Then here, it's 0 again. And then we go back to the beginning and we're at 1. So this is going to be the shape, and everything's rounded. This is going to be the shape of our cosine curve. Sorry. So now we're going to do the sine curve. So it's the same thing. So as we go around our unit circle, we're going to see our y points at these 4 points here. So we're going to start here, and our y output is 0, so we start at 0. Then we go to here, and it goes up to +1. So we'll do 1 here, and we'll do -1 here. So the amplitude of cosine and sine is initially 1, right, for both of them. So it goes from 0 to 1. Then this point, it goes back down to 0. Then this point, it goes down to -1. And then we go back to the original, which is 0. So then you get something that looks like this. Okay? Now, what we call the fact that it goes from 0 to pi, what we call that is the period, right? So the period is the time it takes for one full curve. So this is what one full curve of cosine and sine looks like. That's always what it's going to look like, right? It can shift left and right. So if it shifts left and right, you're just looking for this up, then down, or up, down, then up, right? So these are your standard cosine x, sine of x. Now I'm going to show you the difference between how we can change the amplitude of this function. Now, if you change the amplitude, you do not change the period. The period stays the same. Changing the amplitude is like changing the size of the circle. The circle is larger, however, it's still a circle, right? You're still going around the circle the same speed. So you can think of the x-axis as time and the other axis as like the radius of the circle. So essentially, this means it takes 2 pi seconds to get around the circle, whether we're looking at cosine or sine, right? Now, if we change the radius of the circle, what does that look like for the actual function of cosine x and sine x? So if we change the radius of the circle, we are essentially putting a number in front of sine and cosine. So if we want a radius of 2, what do we need to multiply 1 by? 2. So basically it becomes 2 sine x. And the only difference between this one and 2 sine x okay, we'll put this in. Okay, so the only difference between this one and this one is that now this is 2 and negative 2. And it's going to literally be graphed the same. So it's now going to be graphed like this. Do you notice a difference? No. Now, if we compared them side by side, essentially it's just being 1 point above and 1 point below where this originally was. So if we graph this, it will look like that, right? It's just stretching it out, right? Remember, the number in front that we multiply stretches the function out. So it didn't change how it gets around the circle. It just changed the actual radius of the circle, right? That's it. Okay, so that's what we call, and then basically this number then tells us what the amplitude is. So if you see a 2 in front, then my amplitude is 2. If you see, if you see a 1/2, then my amplitude is 1/2. So this would be it would be smaller here. It would be 1/2. It would be here, right? So that's how we can change amplitude. Okay. The last thing I'm going to talk about is how do we change this period? How does that change? How can we, make it longer or shorter? So to do that, we're now multiplying a number inside to the variable, right? The variable is my input. So it's this 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? Now, to change the period, you put a number in here. Now, the way I want you guys to think about this is if I have sine of x, the number I put in is telling you how much faster or slower you are going around the circle. So if I run a full circle in 10 seconds, and then someone is twice as fast as me runs that same circle, how much time is it going to take them? 5 seconds. So if they run twice as fast, it takes them half the amount of time. So essentially it works the same way for this. If I run twice as fast around the circle, it's going to take me half the amount of time. So in the original sine function, right, it takes us 2 pi seconds to get around the circle because we're looking at this as time, right? So it takes me 2 pi seconds to get around the whole circle. So if I'm running twice as fast, how much time does it take me to get around the circle now? So just like the guy before, it was half the amount of time. So what's half of pi? Pi. So what we do is when we see this, we change the end of our period. So our period now is only pi. In an equation form, period, which is, I use capital T from physics, the period is equal to 2 pi over b. B is the number multiplied in front. So you can always think of it like this as well. T equals 2 pi over b. So we have sine of 2x, and then we're running twice as fast. If we're running twice as fast, it takes us half the amount of time. So half of 2 pi is pi, right? These are nice whole numbers, so it's easy to see it. If you get confused, you can just use this equation here. So now we have 2 points. We need 5 points. We're doing a 5-point system. So how do we get the 5 other points? Well, you cut this in half. What's half of pi? Pi over 2. What's half of pi over 2? Pi over 4, right? Or just dividing by 2. So pi over 2 divided by 2 is pi over 4. Then remember, this is 3/4, so this would just be 3 pi over 4. So now you get these 5 points. How it graphs is identical. What's the amplitude? What's the number in front? There is no number in front, so automatically it's 1. So initially, you can just label this 1 and -1, and it graphs the exact same as we did here. So when we graph sine, it starts off at 0, goes to 1, goes to 0, goes to -1, goes back to 0, and now you've graphed that function. And now you're done. Okay, so that's the last thing I wanted to show you guys for today. Okay, so if we make this 1/2, if I run half as fast, then it takes me twice the amount of time. So this number here would then be what? 4 pi. Okay, so this is what I wanted to show you today. Okay, so here's the whole thing in its glory, right? We graphed cosine, we graphed sine, we graphed 2 of sine x, and we graphed sine 2x. So what I want you guys to do for your worksheet is you are going to graph a sine and a cosine, just a normal sine and cosine yourself, and then I'm going to put a combination of these in afterwards, and you're going to have to graph them. So basically, you're going to draw the regular sine and cosine graph, and then you're going to draw this new sine and cosine graph next to it, not on the same one, but next to it to show the difference. Okay? All right, guys. Have a good night. I'll talk to you guys tomorrow.